Testing a hypothesis by collecting data in controlled conditions. Experiment. An experiment is a test scientists do to learn more about how something works.
Imagine you're trying to find the best recipe for baking chocolate chip cookies that everyone will love. This is similar to testing a hypothesis in science, where you make a guess about something and then gather evidence to see if you're right. In baking, each batch of cookies represents an experiment where you control the ingredients and baking conditions like you would control variables in a scientific experiment. And the feedback from taste testers is your collected data, helping you determine which hypothesis, recipe, is the most successful.
A possible explanation or answer to a scientific question hypothesis. A hypothesis is an educated guess that scientists test through experiments and observations.
Imagine trying to figure out why your favorite plant is wilting despite regular watering. This situation mirrors how scientists approach forming a hypothesis, which is essentially a possible explanation or answer to a scientific question. Just as you might consider various reasons for the wilting, like too much sun, a pest infestation, or poor soil quality, a scientist proposes a hypothesis to explain an observed phenomenon, testing each possibility to find the right solution.
Information gathered through observation. Data. In science, data is the evidence collected during experiments or studies to understand and explain the natural world.
Imagine trying to decide which new restaurant to try for dinner. Just like you might ask friends for their recommendations, skim online reviews, or even walk by to see how busy it is, scientists gather data through observation to understand a phenomenon. In both cases, whether choosing a restaurant or conducting scientific research, you're collecting information by observing the environment and forming a conclusion based on that accumulated evidence.
Explanation of observations supported by evidence. Theory. In science, a theory is a well-substantiated explanation of some aspect of the natural world based on a body of evidence.
Imagine trying to figure out why your car won't start one morning. You might observe that the engine doesn't turn over when you turn the key. Notice that the headlights are dim, and remember that you left the interior lights on all night. In this scenario, you're gathering evidence: dim headlights, a non-responsive engine, and the forgotten interior lights to support your explanation that the car battery is likely dead, much like how scientists construct theories based on observations and evidence. Just as you conclude the dead battery is the reason your car won't start, scientific theories explain observations by piecing together evidence to form a coherent explanation of natural phenomena.
A rule that always works under the same conditions. Law. In science, a law is a statement that describes a consistent and universal principle of nature.
Imagine you always put your phone on a specific shelf when you return home so you never lose it. This habit is similar to a scientific law because just as you can predict your phone's location based on your routine, a scientific law predicts outcomes under set conditions. In both cases, the consistent behavior of always placing your phone on the shelf parallels the reliable outcome of a scientific law when the same conditions are met.
A representation of an object or system. Model. In science, a model is a simplified way to understand and explain complex phenomena.
Imagine you're trying to describe your favorite movie to a friend who hasn't seen it yet. Just like summarizing a movie highlights key scenes and characters to give your friend an understanding without watching the entire film, a model is a simplified representation of an object or system that captures its essential features. In both cases, whether it's the movie summary or a scientific model, the goal is to convey the most important elements clearly and efficiently, allowing others to grasp the main idea without experiencing the whole thing.
The amount of space an object takes up, volume. Volume is the measure of how much space an object occupies.
Imagine trying to pack a suitcase for a vacation, fitting all your clothes and essentials without overstuffing it. This challenge is similar to understanding the volume of an object, which defines how much space it occupies. Just like your suitcase has a limited amount of space to fit everything in, the volume of an object tells us the capacity or the amount of space it can fill or take up, ensuring everything fits within its boundaries.
An object's mass per unit volume. Density. Density is how much stuff is packed into a certain amount of space.
Imagine trying to pack a suitcase for a long trip and struggling to fit everything in. This is similar to the concept of density, where you're trying to fit as much mass, clothes, and items into a limited space, your suitcase. Just as packing more items into the same suitcase makes it feel heavier and more compact, increasing the mass within a given volume increases an object's density, showing how tightly matter is packed together.
The use of scientific observations to solve practical problems. Technology. Technology is using science to create tools that make our lives easier.
Imagine you're trying to find the best route to work during rush hour to avoid traffic jams. This is similar to how scientists use observations to find solutions to practical problems by analyzing patterns and data. Just as you'd observe traffic patterns over time to determine the quickest route, scientists gather observations from the natural world to identify trends and develop effective solutions to real-world issues, like using weather data to predict storms.
The factor that can change in an experiment. Variable. In science, a variable is something that can be changed or controlled in an experiment to test its effects on the outcome.
Imagine you're adjusting the thermostat in your home to find the perfect temperature for everyone. In science, the variable that can change in an experiment is similar to the thermostat setting that you adjust to see how it affects the comfort level. Just as the thermostat setting is a factor you can change to see how it impacts the room's temperature, a variable in an experiment is an element that you alter to observe its effects on the outcome.
The standard used for comparison of test results in an experiment. Control. In science, a control is something kept the same in an experiment to see how other variables change in comparison.
Imagine you're trying to decide if a new brand of coffee wakes you up better than your usual morning brew. Just like you would compare the new coffee to your regular one to see which is more effective, scientists use a control in experiments to compare test results. In this analogy, your regular coffee serves as the control because it sets a baseline to measure the effects of the new coffee, just as a control in an experiment provides a standard for comparison to evaluate the impact of the variable being tested.
A rule that describes what happens in nature. Scientific law. A scientific law is a statement based on repeated experiments that describes a consistent natural phenomenon.
Imagine you're trying to predict when your morning coffee will be ready based on how long it usually takes the coffee machine to brew. Just like the consistent brewing time of your coffee, scientific laws describe consistent patterns observed in nature. The way your coffee machine reliably takes the same amount of time each morning is similar to how scientific laws predict natural phenomena, emphasizing the predictability and regularity both in your kitchen and in the natural world.